Hi guys, welcome back to Mathematics for Engineering 3 Kasetsat University International Programs. Great news! Today is the last section of Chapter 2, okay? And that is the last topic for midterm, okay? But bad news, the midterm is coming, okay? So the midterm is basically the week after the next week. Okay, so today we are going to be talking about Cauchy-Euler equation. Okay, Cauchy-Euler equation. Okay, so first I'll tell you what Cauchy-Euler equations are, and after that I'll show you how to solve them. Okay, so it's just a form of higher order ordinary differential equations. Okay, so let's start. Okay guys, the equation in this form is called a Cauchy-Euler equation. Okay, so they are higher order equations and they can be non-homogeneous, okay, which means that it's not equals 0, right? It doesn't equal 0, okay, and it has the characteristic of Cauchy-Euler is that it has x to the n, x to the n minus 1, and x to the n minus 2, blah blah blah, x, and here no x, which is x to the 0. Okay, it's an x to the n, y to the n, an minus 1, x to the n minus 1, y to the n minus 1, blah blah blah, until a1 x y prime and a0 x to the 0 y, okay, equals r, okay, where the a's are constants, okay, so a's are constants, they are numbers, okay, and r is a function of x, okay, and this equation can be solved basically by substituting x with e to the t. Okay, substituting x with e to the t, and then we use section 3.1, which is the homogeneous, right? The homogeneous higher order to solve it. Okay. If you don't remember, the homogeneous higher order is when we have the characteristic function. We have m, right? The m squared, blah blah blah, and we solve for m, and then we know if we have distinct root, repeated roots, or complex roots. Okay, and that is section 3.1. Okay, so you're gonna see how to do that, but this is the summarize of the Cauchy-Euler equation. So there are three things you need to know. Okay, first is the form. Okay, it's constant times x to the n, y to the n. Sorry, derivative, the nth derivative of y. Constant a to the n, x to the n minus 1 derivative, the nth minus 1 derivative of y. Okay, and blah blah blah, plus a1 x, the first derivative of y, plus a0 x to the 0, which is 1, and y equals sum of functions of x. Okay, so let's look at it a little closer. First, let's consider the Cauchy-Euler equation when x is 0. Okay, we first observe this case. Okay, here as you can see it's Cauchy-Euler because we have x squared and the second derivative. See, this is the specific case, so that we can see how to solve it, and then we can go to more general cases. Okay, so here you see x squared, you see x, the first derivative. See, x squared is followed by the second derivative, x is followed by the first derivative, and y here with no x, which is x to the 0. Okay, it's the zeroth derivative, which is no derivative. So guys, if you see question in this form, you should be able to identify that it is Cauchy-Euler. Okay, and the way to solve it is that first we would let x be e to the t. Okay, first we let x be e to the t, and because of that we know that dx by dt is e to the t, right? Because x is e to the t. Dx by dt is d of e to the t by dt, which is e to the t. Right? Dx by dt is e to the t. So what is dt by dx, guys? What is dt by dx? Okay. Guys, from math 1 or calculus 1, we know that dy by dx is 1 over dx by dy, right? That's a property. So dx by dt is e to the x. So dt by dx is 1 over e to the t, which is e to the minus t. Okay, make sense? Dx by dt is e to the t. Dt by dx is 1 over e to the t, which is e to the minus t. Okay. And guys, what is dy by dx? We need to apply the chain rule, right? Dy by dx is basically dy by dt, dx by dt. Right? That's the chain rule. Dy by dx is dy by dt times dx by dt. Sorry, dy by dt times dt by dx. My bad. Sorry. So that we recovered dy by dx, right? It looks like dt are cancelled out, but it isn't like that. Okay, because you guys are soon to be engineers, so that's why I'm teaching you this way. But it's not mathematically correct. Okay, they can't be cancelled out. Okay, cool. So it would become e to the minus t dy by dt, right? Because dt by dx is e to the minus t. See? Get that? dy by dt is dt by dx is e to the minus t. So we put it here. Okay. And guys, what is the second derivative of y with respect to x? That would be, by definition, is d by dx of dy by dx, right? Then you find the first derivative, and then you find, another derivative, right? You take another derivative, which is, what is it? It would be dy by dx by dt, and then dt by dx, right? Make sense? Guys, the chain rule says that dy by dx is dy by dt by dx, right? So right now we look at this guy as y. Okay, so we want to find dy, the big Y by dx. So what you have is the big Y by dt. See? And then dt by dx. See? So this is the big Y. See? Make sense? Again, guys, we want to find the second derivative, which is the derivative of the derivative, right? But guys, from chain rule, dy by dx is dy by dt, dt by dx. So here we look at this as y. So dy by dx is dy by dt and then dt by dx. Make sense? And if I put things back in there, I would have that it's actually d by dt, but dx by dt is dy by dx is e to the minus t dy by dt. Sorry. Okay, why? Because we have a dy by dx here, which is this guy, so I basically put it here. Make sense? Make sense? And dt by dx is again e to the minus t, right? From here, guys, dt by dx. So here, we need to look at this as u and v, right? So it's derivative of uv, which is u dv plus v du, right? Right, it's a product rule. Okay, so what we have is u dv would be the second derivative, right? You take the derivative of dy by dt, that will be the second derivative, plus v, which is dy by dt. Du will be derivative of e to the minus t, which is e to the minus t, and then you get the chain rule, you get minus here. Okay, and you get e to the minus t. Okay, and then I pull e to the minus t out. So what I have is, what is it? Dy by dt minus dy by dt and e to the minus 2t. Make sense? I pull this e to the t out. Okay, so I have e to the minus 2t here. Okay, then equation star becomes, we just substitute substitute x, dy by dx, the second derivative of y with respect to x into the equation star. So what we have is, what is it? Can I move this a little, lower? I'm afraid I might not have enough space. Okay, so what I have here is a2, right? a2, x squared would be e to the 2t. Okay, x squared would be e to the 2t. Why? Because x is e to the t, so x squared is e to the 2t. The second derivative of y with respect to x would be y double prime minus y prime, right? Okay, let's write it explicitly, because we have dy by dx and dy by dt, right? So to prevent any confusion, minus dy by dt, and then e to the minus 2t plus a2 plus a1, x is e to the x, dy by dx is e to the minus t, sorry, x is e to the t, sorry, f is e to the t, dy by dx is e to the minus t dy by dt, and plus a0 y equals 0. Okay, and guys, as you can see, this got cancelled out. Okay, so what you have is, what is it? It would become a2 by dt, right? This term. Okay, and then plus a1 minus a2 dy by dt plus a0y equals 0. See? So this is the second derivative, first derivative, and these are constant. There are no x anymore. See? So we basically eliminate these terms. Okay? So in that case, it's back to section 3.1. Okay? So this is just to show you that, the Cauchy-Euler equation can be solved with section 3.1. But first, you need to substitute x with e to the t. Okay? Okay, let's look at an example. Here, this example. See, as you can see, is Cauchy-Euler, right? It's x squared second derivative, x first derivative, and no x equals 0. Okay, but here we can't solve it using characteristic function, right? Because for section 3.1, the coefficients here need to be constants. Okay, they need to be constants, but here they aren't. Okay, so first what you need to do is that first you let x be e to the t. Okay, you let x be e to the t. And after that, what happens? What happens is that first you find dy by dx, which is dy by dt, dt by dx, which is dy by dt. Okay, x is e to the x, so dx by dt is e to the t. Okay, sorry, x is e to the t, dx by dt is e to the t. So dy by dx, dt by dx would be e to the minus t. Okay, because dt by dx is 1 over dx by dt. Okay, and guys, again, dy by dx second derivative would be the derivative of the first derivative, right? It's a derivative of the first derivative, but this guy is basically the first derivative. Make sense? Okay, guys, this typo here is dy by dt, sorry. Okay, and then what we have is, what is it? We have d of this guy by dt, and then dt by dx, right? Again, guys, don't forget we have that dy by dx is dy by dt, dt by dx. Now we look at this as a big Y. Okay, we look at this as a big Y. So dy by dx, okay, dy by dx would be dy by dt and then dt by dx. Make sense? Okay, it's from calculus 1. Cool. And this guy is, what is it? Is u and v, right? U and v, right? Guys, I won't recommend you to memorize this, okay? I would recommend you to proceed in this way. Okay, it's gonna be less that you need to remember. Okay, less things you need to memorize. Okay, and this approach can be used for first order, second order, third order, and blah blah blah. Okay, so don't just memorize the formula. Okay, try to understand it. Okay, because here you have the first order y and the second order, so you need to find the first order, the second order, right, in order to substitute this in there and this in there, right? So what you have here is the derivative of uv, okay, and that would be u dv would be e to the minus t, and then you get minus 1, right, plus v, which is e to the minus t, du would be the second derivative, and dt by dx. Okay, Okay, but guys, dt by dx is again e to the minus t. Okay, so what we have here is dy by dt minus dy by dt e to the minus 2t. Okay, I basically pull this guy out and then I just swap between these two terms because here is we have minus here, right? So I put it in the second term. Okay, and then once we have dy by dx, the second derivative of y by x, so we can just plug in into the equation. Okay, so let's call this equation star. So I put x y dy by dx and dy by dx in star. Okay, so what we have is 3 e to the 2t, right? Because x is e to the t, x squared is e to the 2t, y squared would be this guy. Okay, and then plus 6x is e to the t, y prime is dy by dt e to the minus t. Okay, dy by dt e to the minus t. Okay, and then plus y equals 0. Okay, so here again, guys, the same, let's cancel out, right? So what we have is 3 and here we have minus 3, right? And here we have 6, so we still have plus 3 and then plus y equals 0. Make sense? Make sense? Guys, here we have 3 dy by minus 3 dy by dt, and then we have 6 dy by dt, so we have 3 dy by dt. Okay, okay, just in case that if some of you got confused here, so it becomes here. Okay, and this equation can be solved by 3.1, right? Which is to have 3m squared plus 3m plus 1 equals 0, right? Makes sense? And then you might want to try to to factorize it, but then if you have 3m here, you have m here, you figure out that it won't work. It won't work. You can't have 3m squared plus 3m plus 1. Okay, so what you need to know is that you might want to use the formula, or you can use perfect squared. Okay, there are 2 ways that you can do, but the easiest way is to use the formula, okay, which is x equals minus b plus minus square root b squared minus 4ac over 2a. Okay, that's the formula from the secondary school, right? Right now, this is a, this is b, this is c. Okay, so the solution would be minus b, which is minus 3, plus minus square root b squared, which is 9, minus 4a is 3, c is 1, divided by 2a, which is 6. So we have minus 3 plus minus 12, so that would be plus minus square root 3i divided by 6. Okay, okay, and that will be minus 1/2 plus minus square root 3 divided by 6i. Make sense? Make sense? So we basically have two complex roots, okay, which means that our solution would be y equals c1 e to the is minus 1/2, right? Minus 1/2. So it's c1 e to the minus 1/2 t. Guys, right now it's not x, okay? So I shouldn't write x here. I should write m. Okay, right now it's not x because it's the derivative of y by t. Okay, so the solution here, there is no x. See, so it's dy by dt. So your solution for this equation must be in terms of t. Okay, so you have c1 e to the minus 1/2 t, and that is sorry, you have c1 after that. You have c1 cos square root 3 divided by 6t plus c2 sine square root 3 divided by 6t, and that is the solution. Okay, that is the solution, but it's still in terms of t, but you want to answer in terms of x, right? So you have that. You substitute x equal e to the t, right? So we have that t is actually log x, right? So the solution is y equals e to the minus 1/2 log x, okay, e to the minus 1/2 log x, c1 cos square root 3 6 log x plus c2 sine square root 3 over 6 log x, and that is a solution. Okay, if you want, you can do a little bit more by you know that this guy is actually e to the log x to the power of minus 1/2, right? You just push this up here, okay, and the log and e got cancel out, so you get x to the power of minus 1/2. So you can write the solution as x to the power of minus 1/2 c1 cos square root 3 divided by 6 log x plus c2 sine square root 3 divided by 6 log x. Okay, and that's it. That is the solution. See, it's actually not hard. The idea is that first you let x be e to the t, okay? Because you can't solve this equation with section 3.1 because the coefficients, they aren't constants, right? In 3.1, the coefficients must be constants. Okay, so you let x be e to the t, and then you find dy by dx, the second derivative of y by x. If you have the third derivative term, so you need to find the third derivative of y by x, and blah blah blah. Okay, and after that you just put all the derivatives and x into this equation, okay, and then you will end up with the homogeneous, okay, second order equation where the coefficients are all constants. Okay, I'll write down here is constant coefficients. See, the coefficients are constant, so it's back to chapter 3.1. Okay, so we can introduce the characteristic equation, and then we can solve the characteristic equation, and then we get the solution, right? And that's the matter of 3.1. After that, once you get this solution, don't stop there. Okay, because the solution there is in terms of t. Why? Because we solved the equation where the independent variable is t. See, it's not x. So the solution must be in terms of t. Okay, so we want to answer in terms of x, right? So we let x be e to the t, and then t is log x, and then we just substitute that back, and then we get the solution. As simple as that. Okay, okay, cool. Next, guys, what should we do if we have Rx? Okay, let's say if Rx is not 0. Okay, the first case we looked at is when Rx is 0. But how about if it's not 0? Okay, we can first find y1 and y2 from here, right? Right? And to find that, we would let x be e to the t, right? And then we find dy by dx, dy squared by dx, and then we put all of these in the equation, right? Right? So we can obtain the two solutions, right? Because it's a second order equation. We should get y1 and y2. Okay? And after that, once we have y1 and y2, we can just use the variation of parameters, okay, which is section 3.2, to solve the equation star. Okay, so we first find the two solutions, okay, when Rx is 0. Okay, it's the same concept. It's the same concept as when we do variation of parameters, right? First, we find v1 with y1, y2 by letting r be 0, right? And after that, once we get the two solution, we write the general solution in terms of a1x, a1 y1 plus a2 y2, right? Right, and then we use the variation of parameters, right, in order to obtain a1 and a2, and then we get the solution. Okay, but don't forget, guys, this is very important. Okay, and I believe that many of you get it wrong. The thing that you need to be very careful is that the coefficient of the highest order, the coefficient of the highest order must be 1. Okay, it must be 1, right? Because, if we go back to the variation of parameter, here, variation of parameters, we first look at this equation, right? Right? And the coefficient here must be 1. Okay? As you see from this example. Here, see? Here, it must be 1. Right? As I already emphasized that to you, right? The coefficient of y to the n is 1. Okay? Here, when we were solving this example, see? We have 2 here. So first, we need to divide the whole equation by 2, so that this becomes 1 first, and then we can apply the variation of parameters. Okay? So that's just the thing that you should be aware of. Okay? So let's look at an example. Okay, solve this equation, and as you can see, is clearly Cauchy-Euler, right? Because we have x squared and we have x here. Make sense? Make sense? So we first need to find y1 and y2 when x squared y double prime minus 4x y prime plus 6y equals 0, right? That is the variation of parameters technique. Okay, and to do that, first we let x be e to the t. Okay, we let x be e to the t. So dx by dt is e to the t, or dt by dx is e to the minus t. Okay, and that's what we have. Okay, and we have that dy by dx is dy by dt, dt by dx, which is dy by dt e to the minus t. Okay, and then the second derivative is d by dx of dy by dx, right, which is dy by dt and e to the minus t. Okay, and that is dy by dt. Oops, sorry. That is dy by dt e to the minus t d by dt times dt by dx. Okay, and what is it? d by dt, dy by dt is, we need to use udv plus vdu, right? So we have dy by dt e to the minus t minus 1 plus v du, dt by dx is e to the minus t. Okay, so we have that is actually dy by dt minus dy by dt e to the minus 2t. Okay, I know they are the same for, you know, the second order, but I won't recommend you to memorize it. I would just, you know, we just write it down, okay, to save space in your brain, okay, to save the memory, okay, to keep the memory. So here I'll call this equation star. So I substitute all into the equation star. So what we have is, what is it? Is e to the 2t. Okay, y double prime is dy by dt. Here we have t minus dy by dt e to the minus 2t minus 4. X is e to the t, y prime is dy by dt e to the minus t plus 6y equals 0. Okay, right now, sorry, I substituted to, not to the equation star, I substituted to the equation double star here. Okay, in double star, because right now we are solving the case when Rx is 0. Okay, so what we have is, what is it? These cancel out, so what we have is dy by dt minus 5 dy by dt plus 6y equals 0. Okay, dy by dt minus 5 dy by dt plus 6y equals 0. Make sense? Make sense? Okay, and we can have the characteristic equation, which is m squared minus 5m plus 6 equals 0. Okay? Okay? And in that case, we have that is m 3 and 2 minus n minus, so m is 2 and 3. So we have that y1 is actually e to the 2t and y2 is e to the 3t. Okay? Okay? And once we have y1 and y2, so here we have that y1 is e to the 2t, which is e to the 2, but x is e to the t, right? So t is log x. And y2 is e to the 3 log x, which means that y1 is actually e to the log x squared and y2 is e to the log x cubed, which means that y1 is x squared, y2 is x cubed. Okay? Make sense? Make sense? Okay? And after that, we look at the variation of parameters technique, right? So we can write down the solution y as a1 y1 plus a2 y2, which is a1 x squared plus a2 x cubed. Okay, guys, if you don't remember the variation of parameters technique, go back to the second to 3.2, right? Okay, just go back to that section. Okay, so third, you obtain the system of linear equations, right? Which is you have y1, which is x squared. Okay, let me write it down. You have y1, y2, y1 prime, y2 prime, a1 prime, a2 prime, and then you have 0 and r, if you remember. Okay, you have 0 and r. So what you have here is x squared, x cubed, 2x, 3x squared, and then you have a1 prime, a2 prime equals 0 and r is x cubed. Okay, so by Kramer, we have that a1 prime is basically the determinant of this guy divided by the determinant of this guy, which is basically minus x to the 6th divided by what is it, 3x to the 4 minus 2x to the 4, which is minus x to the 6 divided by x to the 4, which is minus x squared. Okay? Okay. And a2 prime is, what is it? It would be x squared to x, 0, x cubed divided by x to the 4. Okay, because here is the same. It's always the same. So you don't need to compute it again, okay? So here you have x to the 5 divided by x to the 4, which is x. Okay, so you have that a1 is actually integrate, okay, of a1 prime dx plus c1. Okay, and that is, what is it? Integrate of minus x squared dx plus c1, and that's minus x cubed divided by 3 plus c1. Okay, and a2 is integrate of a2 prime dx plus c2. Okay, and that would be integrate of x dx plus c2, and that would be x squared divided by 2 plus c2. Okay, and that is a1 and a2. Okay, but don't forget guys that the solution is in terms of a1 x squared plus a2 x cubed. So the solution would be y equals a1, which is minus x cubed divided by 3 plus c1 x squared plus x squared divided by 2 plus c2 x cubed, which is, okay, you can just stop here, and that is the solution. And right, that is the solution. Is it correct? No, it's not correct. It's wrong. It's wrong. It's wrong, guys. Why? Guys, why is it wrong? Because I emphasized, okay, before that you need to be very careful that the coefficient of the highest order must be 1. Okay, the coefficient of the highest order must be 1, right? But if you look here, you obtain y1 and y2. There's no problem about that. Okay, there's no problem about that. And after that, you're gonna be solving this equation, right? You're gonna be solving this equation using variation of parameters, right? Right? But you can see here, the coefficient is not 1. See, it's x squared. It's x squared. Okay. Okay. So before you actually proceed here, you should have this line first. Okay, let me pull this down a little bit. You should change this equation to y double prime minus 4 over x y prime plus 6 over x squared y equals x. See? Basically, you need to divide the whole equation here by x squared, so that the coefficient here is 1. Okay, and the reason I've been showing you here is that I want you guys to know that even if you forgot to change this coefficient, you still get the answer, but the answer is just wrong. Okay, and you will get out of the exam being so happy, okay, that I can get this question, Cauchy-Euler, so easy. But when you know the score, it seems like you get less than expected, maybe because of this. So don't forget, guys. Okay. So if we look at this equation, the thing that needs to be changed is here. R here is not going to be, it's not going to be x cubed anymore. It's going to be just x. See? But the rest is the same. Okay, so here from x cubed, it will be just x, because right now here is our r, right? So it's x. So here would be minus x to the 4. Okay. So here it's just minus 1. Make sense? And here is x. So we have x cubed. So here is 1 over x. Make sense? So a1 is integrate minus 1, which is minus x, plus c1. And a2 is integrate 1 over x, which is log x, plus c2. So the answer would become a1, which is minus x plus c1. Okay, y1 is x squared plus c2, a2, which is log x plus c2 and x cubed. Okay, and that can be written as c1 x squared minus x cubed plus x cubed log x plus c2 x cubed. But guys, here as you can see, we have plus c2, right? Here, can I write here? Y would be just c1 x squared plus c2 minus 1 x cubed plus x squared log of absolute x. But guys, c2 is a constant, right? c2 is a constant. Okay, c2 is a constant. So c2 minus c1 is still a constant. Okay, so it's just another constant. So I'll just write like this. Okay, and that would be the right answer. Okay, make sense? Okay guys, let's look at another example, which is this one. So it's x squared y double prime minus x y prime minus 3y equals x to the 4 log x. Okay, for that one we have that first, okay, it's clear that is Cauchy-Euler. Okay, so first we need to find y1 and y2 by x squared y double prime minus x y prime minus 3y equals 0. Okay, I call this equation star. I call this equation double star. Okay, so we let x be e to the t. So dx by dt is e to the t, and dt by dx is e to the minus t. Okay, and dy by dx is dy by dt. Guys, it's a good practice to keep writing it down. Okay, to keep writing it like again and again. Okay, it will help you to remember them. Okay, so it's dt by dx. So dy by dt and dt by dx is e to the minus t. And the second derivative would be d by dx of dy by dx, which is d by dx of dy by dt e to the minus t. Okay. And we have that, guys. It's squared here. Okay, so is udv plus vdu, right? We have done that many times, so I'm gonna go a little bit quicker. Okay, so we have u dv plus v du. Okay, and guys, I forgot dt by dx, so we have dt by dx here. But as we know, dt by dx is, just change it. Okay, guys, I'm sorry. dy by dx is dy by dx is actually this guy, so we put it here. Okay, and because we want to find d by dx, so we find d by dt and dt by dx. Okay, and here dt by dx is e to the minus t, so we have here d by dt minus dy by dt e to the minus 2t. Okay, and then we put in double star. Okay, so what we have is, what is it? We have e to the 2t, okay, x squared, which is e to the 2t. Y double prime is by dt minus dy by dt. Okay, it looks a bit like x, so I'll write it a little better. So it's e to the minus 2t minus x, which is e to the t. Y prime is dy by dt e to the minus t minus 3y equals 0. Okay, and here cancel out again, and we have that is by dt minus 2 dy by dt minus 3y equals 0. Okay, and then we obtain the characteristic equation, which is this guy, and that is m3 1 minus plus. Okay, which means that y1 is e to the minus t, y2 is e to the 3t. Okay, I should have written another line, which is this line. M is minus 1 and 3. Okay, so we have y1 and y2. Okay, but we need to write them down in terms of x, right? So we have that y1 is e to the minus log x, which is e to the log of x minus 1, which is, let's cancel out, which is 1 over x. Okay, e to the minus 1, which is 1 over x. y2 is e to the 3t, which is e to the 3 log x, which is e to the log x cubed, which is x cubed. Okay, then guys, we write down that y is actually a1 y1 plus a2 y2, right? So third, we have, okay, write down here. A1, y1 is 1 over x, and a2, y2 is x cubed. And then third, we have the system of linear equations, which is 1 over x, x cubed. Here will be minus 1 over x squared. Here will be 3x squared. And then we get a prime, a2 prime. And then we get 0 and x to the 4 log x. Right? Right? No, wrong. And no. Right? Because here, if you look here, the coefficient here is x squared. Right? So we need to divide the whole equation by x squared. Okay? So r here would become x squared log x. Make sense? So r here is not x to the 4 log x. It should be x squared log x. Okay? Does it make sense? Cool. So we have a1 prime equals the determinant of 0 x squared log x, x cubed, 2x squared divided by 1 over x, x cubed, minus 1 over x squared, 3x squared, and that is 0 minus x to the 5 log x divided by 3x plus x, which is minus x to the 5 log x divided by 4x. Guys, I hope you guys can, now compute the determinants. Okay, which is minus 1 over 4 x to the 4 log x. Okay. And a2 prime would be the determinant of 1 over x minus 1 over x squared, 0 x squared log x divided by 4x, and that would be x log x divided by 4x. 4x cancel out, and that would be 1 over 4 log x. Okay, so a1 is integrate a1 prime dx plus c1, and that will be integrate of minus 1 over 4 x to the 4 log x dx plus c1. Guys, I'm not gonna show you how to integrate it. Okay, I'll just give you the result. If you want to know how to integrate it, you first try it yourself, and if you can't find it, if you can't manage, just let me know. And a2 is integrate of a2 prime dx plus c2, and that would be integrate of 1 over 4 log x. This is integration by part, right? If you remember. Okay, you can try them. It's integration by part. So here what you have is x over 4 log x minus 1 plus c2. Okay, so the solution would be y equals y a1 y1 plus a2 y2. Okay, which is, what is it? A1 is x 100 1 minus 5 log x plus c1, and then y1 is 1 over x. Okay, plus a2, which is x over 4 log x minus 1 plus c2, and y2 is x cubed, and that is the answer. Okay, okay, that is the answer. Okay, guys, see, it's not so hard, right? We begin with if Rx is not zero, for Cauchy-Euler equations. First, we want to find y1, y2, y3, y4, y5, depending on what orders we are looking at, right? If it's second order, we try to find y1 and y2, and we assume that R is zero for now. Okay, we look at the homogeneous case, right? And then we substitute x with e to the t, right? We get dy by dx, the second derivative, the third derivative, and blah blah blah. Okay, and then we put that in the equation, right? And then we solve it using 3.1, right? The homogeneous case when the coefficients are constants, right? And once we solve that, we get y1, y2, y3, right? After that, we write the solution in terms of a1, y1 plus a2, y2 plus blah blah blah, right? And then we obtain the system of linear equations using the section 3.2, which is variation of parameters, right? And that is what you need to be very careful is that you need to determine Rx correctly, because don't forget, guys, the coefficient of the highest order must be 1. Okay, so Rx, you need to divide the whole equation by the coefficient of the highest order first in order to obtain Rx. Otherwise, things will go wrong. Okay, as you already see. Okay, and after that, you get a1 prime, a2 prime, blah blah blah. So you get the a's, right? You get the a1, a2, a3. So you can write down the solution. That's it, guys. Okay, so hope it's not too hard for all of you. Okay, and we are done for the exam, the midterm exam. So good luck, guys. And okay, luck doesn't really help. Okay, but I'll still say good luck. Okay, maybe it does help a little bit, but it actually doesn't help much. So doing exercises helps. Okay, so guys, do exercises, do the homeworks, do the hard exercises, and try to practice. If you have any questions, try to contact me. Okay, and yeah, and try to do your best in the midterm exam. So see you after the exam. Okay, hope you guys are still with me. Okay, through the end of the term. Okay, bye bye.